nomenclature in chemistry, previously I mentioned the general nomenclature trick that should be locans, then hyphen prefix, then hyphen parent, then hyphen locans, then hyphen last one suffix. Okay. Suffix that should be written after parent and prefix that should be written before parent. Okay. There is no confusion. Next one, numerical prefixes. Now numerical prefixes we used. First one, the prefix is used as mono. Mono signifies that is there must be one and only functional group. That is for to designate that is one, we have to consider the term mono. Okay. As for example, that is first one, monoperoxy terephthalate acid. Monoperoxy terephthalate acid. Why this is called as monoperoxy? Because peroxy means that is O bond O. This type of group is there and that should be present in one time only. That's why we termed as monoperoxy terephthalate acid. Actually this is termed as terephthalate acid, but there should be peroxy group is present in one time. So we can say that is monoperoxy terephthalate acid. Okay. This is hexandioic acid, but there should be one peroxy group is present and that should be one time. So that's why we termed as monoperoxy hexandioic acid. Monoperoxy hexandioic acid because there should be peroxy is present but one time. That's why we called as monoperoxy hexandioic acid. Okay. There should be phthalic acid. Phthalic acid. Okay. If we consider that is their spelling, you can say phthalic acid for ignoring the spelling mistake, but if we pronounce this, we have to consider phthalic acid. So phthalic acid monomethyl ester. Okay, this is not CH2, this should be CH3. Okay, and this term is one and only time used, and only one methyl esters are present in that case. So that's why we say monomethyl ester. Phthalic acid monomethyl ester. Okay. There should be monothioglitcerol. As we know, okay, this is termed as methanol. Okay. If we termed as CH2OH and CH2OH, that should be termed as ethylene glycol. If CH2OH and bond CH2OH is present, that should be termed as ethylene glycol. Okay. But if we termed as CH2OH, CHOH and CH2OH, that should be termed as ethylene glycol. That should be termed as glycerol. CH2H bond CHOH bond CH2H, that should be termed as glycerol. So in that case, in one and only OH, that should be replaced by SH. As we know, when any atom replaced by sulfur, we termed as thia. Okay. When any OH that should be replaced by SH, we can term this thia. Right? By this way, we can say that is one and only one OH replaced by one and only one SH. So we can term it as monothia. Because one OH is replaced by one SH. So we can term as mono. Okay. So by this way, we can say monothioglitcerol. Monothioglitcerol. So that should be clear. The whole of the skeleton is glycerol. And there should be the Twist is one OH is replaced by one SH, and due to replacement of SH we can term as monothioglycerol. Okay. Next one, numerical prefixes by, tar, quarter, they are also used. By for use 2 times functional group is present. Tar means 3, there should be tar means 3, okay. I think not 3, and quarter means 4, okay. By means 2 times, tar means 3 times, and quarter means 4 times. There should be some examples are there. First one, biphenyl. You know biphenyl, that is 2 benzene are fused to each other. Biphenyl, you know that is if biphenyl having hydrogen and fluorine group, fluorine or hydrogen group, or sometimes deuterium group, that is these biphenyls are planar in nature, okay. They are planar in nature. But other functional group, that is which are bulky, that is as for example SO3H, COOH, so on. So there should be one benzene ring is planar, other benzene ring is perpendicular, okay. Other benzene ring is perpendicular, depend upon the functional group. If functional group is hydrogen, fluorine and deuterium, there should be no repulsion at all, so 2 benzene ring can be exist as planar orientation, almost planar, okay. But when bulky group, as for example COOH, SO3H, they are present, on that case most of the cases biphenyl exists, one is planar benzene ring, other is perpendicular. So there should be gap is in biphenyl system, we get this type of gap, this, okay. There should be benzene ring, and there should be benzene ring, that is A, that is must be A, that is must be B, and that is must be B. There must be repulsion in between of AA and BB, okay. In that case there should be perpendicular form is exist, in that case there should be perpendicular form is exist, and this form is exist in this type. Now the question is, in that position which type of configuration can be exist? In that position, the exists, this is benzene ring, and there should be benzene ring, this is A, this is B, and this is B, this is A, okay. This is less energetic than the previous one. Previous one what is? That is previous one is this, that is AA, BB, okay. We can learn this later, okay. So that is biphenyl system. That's why we termed as bi. Bi means 2 times benzene are attached, okay. Next one, terphenyl. There should be 3 benzene ring are attached, that's why we termed as terphenyl. There should be, these numbers are used, that is the linkage of between of them, okay. How we can conclude? That should be, there must be in one position attached with other 1 prime position, okay. There must be 4 prime position attached with other 1 double prime position, okay. In one benzene ring, 1 position attached with other benzene ring at 1 prime position, okay. In second benzene ring attached with third benzene ring with 4 prime 1 double prime linkage. So that's why we overall call 1 prime, 4 prime 1 double prime terphenyl, okay. There should be same, this is quarter terpyridine because 4 times pyridines are attached, okay. The linkages are, these are present, that is must be 2 position of 1 pyridine attached with other 2 prime position, 6 prime position attached with other benzene ring at 2 double prime position, and 6 double prime position attached with other 2 triple prime position, okay. By this analogy we can say 2 prime, 6 prime, 2 double prime, 6 double prime, 2 triple prime, quarter pyridine, okay. Now the numerical prefix is di, tri, tetra. Okay, these are Greek derivative except a few terms, that is nona and deca, which are basically derived from Latin words. Okay, in chemistry many of the terms can be come from Greek letters and many of the terms that should be used by Latin words. Okay, so most are Greek derivative, but except few terms, that is nona and deca, that should be come from Latin, which are commonly employed to indicate multiplicity of substituent suffixes, conjunctive components. How many times the functional groups or attachment of some heteroatoms that should be there, that should be designated by the terms prefixes di, tri, tetra. Okay. Replacement affixes present in same atom and or different atom. Okay. So that is the funda is, that is di, tri, tetra, that is Greek derivative. Okay. Except few, that is nona and deca, came from Latin words. Commonly employed to indicate the multiplicity of substituent suffixes, means how many times the prefixes or suffixes are there. The term, if there must be one and only one functional group is there, so we used as mono. Okay. If two is there, we use as di, or sometimes we can use bi also. As for example, biphenyl. Okay. For 3 we use tri, 4 we use tetra, 5 we use penta, 6 we use hexa, 7 we use hepta, 8 we use octa, and 9 for nona. Okay, 1 for mono, 2 for di or bi, both can be used. 3 for tri, 4 for tetra, 5 for penta, 6 for hexa, 7 for hepta, 8 for octa, and 9 for nona. These are most used. Okay, these are not so much used, but we have to consider these all things. Okay, for 10 number functional group are present, so we can say deca, 11 undeca, 12 dodeca, 13 icosa, 14 pentacenta, and 15 hecta. Okay. Okay, let me check. 14 pentacenta, 15 hecta. Okay, this I will be check again. Okay, so this is important. Next one, numerical prefixes bis, tris, and tetrakis. Okay, there should be the derived by adding kis to the simple numerical prefixes. Tetra plus kis, that is ultimately you get tetrakis. Okay, there should be only adding of kis term. Okay, this is also used in place of di, tri also. Sometimes in place of di and tri we use bis, tris, so on. Or sometimes in many IUPAC nomenclature there are already bi, tri, tetra are given in the naming. So on that case, for number of functional group we can use bis, tris, tetrakis type of prefixes. Okay, examples are there 1 for bis, 3 bromo propanoyl piperazine. Okay, there should be 1 for bis, 3 bromo propanoyl piperazine. If we consider 1, 2, 3, 4. Okay, 3 bromo propanoyl, 3 bromo, 1, 2, 3, 1, 2, 3. I think 1, 1, 2, 3. Okay, and there should be 1, 3. There must be, this maybe is not there. Okay, I have to consider. Okay, that should be check. Propanoyl, 3 bromo propanoyl piperazine, that is 1 for bis. I think there should be COO group is there. Okay, that's why we can say that is 3 bromo propanoyl, and that is 1 and 4 position. If we consider 1 nitrogen is 1 and other nitrogen, that should be 4, because in between of 2 nitrogen there must be 2 CH2 is there. So that is in 1 position and 4 position 3 bromopropanoyl group is present, and that is overall we can say piperazine. That is 1,4-bis 3 bromopropanoyl piperazine. Okay. Next one, cyclobute 3N12 bis ilium. Ilium, why? Because there should be di positive. This is also positive. Okay, di positive. That's why we can term as 1,2 bis ilium. 1,2 bis, why? Because in that position we termed as 1 and 2. That is, must be this term is there. They are positive, they are also positive. This is numbering in that position 1 and 2. Okay, then we can term as 3. So 3 position having 1 double bond. So we can say 3 in. So overall the skeleton is cyclobutene. Right, overall the skeleton is cyclobutene. And as there must be 2 carbocation is produced, so we can say cyclobute 3 in hyphen 1,2 bis ilium. Okay, next one. There should be cheese 1-argidinyl phosphine sulfide. Okay, cheese because agiridinyl group is this. This is termed as agiridinyl. That should be present in the structure 3 times. That's why we termed as cheese. Okay, agiridinyl is this type of unit, and that should be present in 3 times. So we can say cheese hyphen agiridinyl. Okay. Overall the compound is phosphine sulfide because there should be P double bond S linkage are there. So we can say phosphine sulfide. So overall the structure name is cheese hyphen 1-argidinyl, because 1 we can say that is at 1 position nitrogen, the whole over 1 position of the nitrogen or phosphorus, we can say phosphorus, from phosphorus we can say 1 position, that is 1-argidinyl is as a unit is attached. So we can say cheese 1-argidinyl phosphate sulfide because there should be P double bond S bond is there. Okay, there must be 3 carbocations are developed, so we can say cheese ilium. Okay, and if we put any numbering system in that case, we can say 1, 2 and 3, right? By this way we can say 1, 2, 3 cheese ilium. 1, 2, 3 is nothing but this is a position of carbocation. So we can say 1, 2, 3 cheese ilium. Propan 1, 2, 3 cheese ilium. Okay. Next one, bis diethyl thiocarbonyl disulfide. Okay. Bis diethyl thiocarbonyl means what? This type of unit. Diethyl, 2 ethyl group are present. Thiocarbonyl means what? C double bond S. Okay, diethyl thiocarbonyl, C double bond S, because C double bond O is termed as carbonyl and C double bond S is termed as thiocarbonyl, and disulfide because present in the S bond S linkage. So we can say bis diethyl thiocarbonyl disulfide. Okay, next one, 3,3-bis para hydroxyphenyl phthalate. Okay, there should be bis para hydroxyphenyl because 2 para hydroxyphenyl group are present, because OH is present at para position. Okay, with respect to C. With respect to C, OH is present at para position. Okay, so we can term as para hydroxyphenyl, and that should be present in 2 times. At what position? At 3 position. Okay, if we consider at 3 position, basically in this carbon is 3 position. So by this way we can say 3,3-bis para hydroxyphenyl phthalate. Now prefix bicyclo. Bicyclo are used basically this type of compound. Okay, like for example this type of compounds are termed as bicyclo. Used for a saturated alicyclic hydrocarbon system consists of two rings only which have two or more atoms in common. There should be two rings are fused, but there must be one or two atoms are common to both of the rings. That should be termed as bicyclic structures. Okay, that should be saturated alicyclic hydrocarbon system, and that should be consist of two rings only which have two or more atoms in common. Used as number of carbon atom in brackets. That is, the number of carbon atoms are written in the bracket, within the bracket. Okay. So, bicyclo means is a bicyclic system having two or more than one or two or more than numbers of atoms in common, and that should be are saturated. Most of the cases they may have double bond, triple bond, not triple bond, double bond. In that position we can say, I'm sorry, this type of complex can be there, but most of the cases we can term as saturated alicyclic hydrocarbon. There is no benzening, so this is not a benzoate system. This is non-benzoate system, and there must be most of the aromaticity not found. Okay. In bracket we use the number of carbon atoms are present in each of the ring. Okay. How we retain the brackets? Maximum number of carbon atoms, then median number of carbon atoms, last one lowest number of carbon atoms. If is present this type of complex, there should be in both of cases 1, 2. 2 carbons are present, 1, 2. 2 carbons are present, and there should be 1 carbon is present. So bracket 2, 2, 1. Okay, this type. A punctuation is very important. If we do not pronounce in good manner, so there must be some complexity is arised. Okay. So examples are, first one, that is bicyclo 2,2,1 hep2ene. Hep2ene, first one we consider hept. Hept means why? Because if we consider the number of carbon atoms 1, 2, 3, 4, 5, 6 and 7. So we get hept. That is because 7 number of carbon atoms are present. Okay, so we can say hept. 2-ene, because if we consider in that position 1, so there should be 2, and 2 position bear 1 double bond. So by this analogy we can say hep2ene. Okay. Now we designate why it is called bicyclic, because the two rings are fused to each other. There must be 1 carbon atoms are common in both of them. So that's why we termed as bicyclic. Now we justify in bracket 2, 2, 1. There must be 1 and 2. 2 carbon atoms are present. There must be 1 and 2. 2 carbons are present. And in that position 1 carbon are present. So first we written maximum number of carbon atoms present in any site, we get 2. Mid number of carbon atoms present in any site, that is also 2. And lowest number of carbon atoms present, that should be 1. So we get bicyclo 2,2,1 hep2ene. Okay. Next one, bicyclo 3,2,1 octane. If we consider number of carbon atoms, that is 1, 2, 3, 4, 5, 6, 7 and 8. So we get octane. Okay. This is a bicyclo because 2 rings are fused to each other. There should be 1 carbon atoms are common. So that is, it must be fulfill the criteria of bicyclic compound. So we can say bicyclo octane. Now consider 3,2,1. Why the bracket 3,2,1s are given? So we have to consider the highest number of carbon atoms present in what site? Highest number of carbon present in that site. That is 1, 2, 3, 4 and 1, 2, 3. Okay. One, 2, 3. I think there should be mistake. We have not considered this side. We have considered only this side. 1, 2, 3. So there should be 3. Then again 1, 2. That is 2. Last one this. That is 1. We do not consider these things. Okay, these fused carbon atoms. We cannot use these common carbon atoms. In some common region, two rings are fused to each other. Not only two rings, basically two rings are fused to each other. These carbon atoms are not considered. We only consider the free one carbon atoms which having only exist in one ring, not the common area. We do not consider the common area where the two rings are fused to each other. We only consider the free area where only one ring exists. Okay, so there should be one carbon, one carbon, one carbon. So overall we get 3. The highest number we get 3 point. Then one carbon, one carbon. So we get 2 again. And last one, this carbon. That is we get 1. So overall we get what? That is bicyclo 321 octane. Okay. Now we consider bicyclo 368 trioxa bicyclo 322 nonene. Nonene, why? Because if we count the number 1, 2, 3, 4, 5, 6, 7, 8, 9. So overall the number of carbon and oxygen atom, the sum of carbon and oxygen atom, that should be 9. So we get nonene. Here we also consider number of oxygen atoms also, because oxygen atom is nothing but it is a replacement of CH2. Okay, so that's why oxygen number of oxygen atom also considered. So sum of number of oxygen atoms and carbon atoms is equal to 9. So overall we have to consider the whole over the rings is nonene structure. Okay, this is also bicyclic structure, and there should be trioxa because 3, 6, 8 position having oxygen atom. If we consider this is 3, 4, 5, 3, okay, 1, 2, 3, 4, 5, 6, okay. If we consider 1, 2, 3, 4, 5, 6, 7, 8, 9, okay. So in 8 position 1 oxygen is present, in 6 position 1 oxygen is present, and in 3 position 1 oxygen is present. So that's why we can term as 3, 6, 8 trioxa bicyclo. And 322, why we termed as 322? 1, 2, 3. There must be 3 carbons, 3 atoms are there. Next one, 1, 2. There must be 2 atoms are there. And there must be 1, 2. That is 2 atoms are there. So we termed as 3, 2, 2. Okay. Now we consider spiro. Spiro means there must be this type of structures are termed as spiro. There must be this type of cross sections are there. This is termed as spiro. Okay. One atom are common of both of the rings. Okay. This is termed as spiro. There must be this type of orientations are there. Spiro 3, 4 octane, because if we consider whole over the carbon atoms, that is 1, 2, 3, 4, 5, 6, 7 and middle 8. So overall octane. That is justified. Overall compound is spiro. Okay. And spiro 3, 4, because there we have to consider the highest number of carbon atoms in any site. So there must be highest number of carbon atoms in that site. 1, 2, 3 and 4. Okay, and there should be 1, 2, 3. For spiro we have to consider opposite trend. We use first lowest number of carbon atoms, then highest number of carbon atoms. Okay, that is the main difference of bicyclo and spido compounds. In bicyclic compound, we have to consider in bracket that is highest number of carbon atoms, then mid number of carbon atoms, then lowest number of carbon atoms is present in any side of the ring. And spido compound, we have to consider in bracket lowest number of carbon atoms, then highest number of carbon atoms. So in spido compound, in that compound, there should be in one side 4 carbon atoms are there, in other side 3 carbon atoms are there. So we have to consider in bracket 3 then 4. Okay, that is the opposite trend of bicyclo compounds. Other example is this. Okay, other examples are this. That is spido 4 5 decane, because this 1 3 4 5 6 7 8 9 10, there must be 10 carbon atoms, so we get decane. Okay, then that's decane. So the compound is overall spido, and as we know there must be 4 carbon atoms are present and there should be 5 carbon atoms are present. So we have to consider in bracket opposite of bicyclo compound, that is first one 4, then point, then 5. Point or comma, there should be 5. This is the nomenclature of bicyclo and spido compound. Now after this we consider the comma, colons, hyphen, full stop used. Okay, spaces. Okay. Now up to this. So what is the summary? Summary is there should be numerical prefixes that are used, that is di, tetra. Most are Greek derivative except few terms, that is nona and deca, that should be come from Latin words, which are commonly employed to indicate the multiplicity of substrain or suffixes or prefixes that should be present. Okay. There must be for 1 we use mono, for 2 we can use di or bi, 3 that is tri, 4 for tetra, 5 for penta, 6 for hexa, 7 for hepta, and 8 for octa, and 9 for nona. That is our most used. But less used, that is 10 for deca, 11 for undeca, 12 for dodeca, 13 for icosa. And 14, 15 there should be, I check again, but 14 pentacenta and 15 hepta. Okay, we have to, we check again this term. Okay. Next one, numerical prefixes bis, tris, tetrakis. There must be some of the cases, that is the prefix plus KIS, adding we get this type of numerical prefixes. That should be used in place of ditype, or sometimes in UPSC nomenclature already ditypes are given. So in that case, for designate the multiplicity of prefixes or suffixes, we can use bis, tris, tetrakis, so on. Okay. There must be so many examples are there, that is cyclo, but, 3n, 1, 2 bis, ilium, because in two position carbocations are present, so we can use that is 1, 2 bis, ilium. Okay. Similarly, tris, 1 azeri, dinyl phosphine sulfite. There should be 1 azeri dinyl is a unit that should be present in 3 times. So that's why we use tris. Tris hyphen in bracket 1 azeri dinyl phosphine sulfite. Similar things can be occur in other examples also. Next one, prefix bicyclo. Bicyclo use basically designate there must be 2 rings are fused to each other. 2 rings consist and which have 2 or more atoms in common. Okay. And there most of the cases they are saturated alicyclic hydrocarbon. Maybe sometimes double bonds can be there. But always remember beachhead position having double bond or carbocation is very much unstable, can be designated by benzone. Okay. And there for IUPAC nomenclature we can use in bracket, that is for bicyclo maximum number of carbon atoms, then mid number of carbon atoms, and last one lowest number of carbon atoms. If maximum mid number of carbon atoms and lowest number of carbon atoms are equal, so there must be no confusion, that is the same numbers are put in the bracket. If maximum number of carbon atoms and mean number of carbon atoms are same, so that is also same, that is same number of atoms are same number of numbers, same numbers are written in the bracket. If all of the cases maximum number of carbon atoms, mean number of carbon atoms and lowest number of carbon atoms all are same, so we have to consider three numbers in the in the bracket. Like for example, if maximum number of carbon atoms is 2, mean number of carbon atoms also 2, but lowest number of carbon atoms is 1, so in bracket we have to written 2 2 1. If maximum number of carbon atoms is 3 and mean number of carbon atoms is 2 and lowest number of carbon atom is 2, so you have to consider 3 2 2. Okay, but if there should be maximum number of carbon atoms is 3, mean number of carbon atoms that is also 3 and lowest number of carbon atoms that is also 3, we consider in bracket 3 3 3. Okay, this is the example. For Spiro, we have to consider in bracket first one lowest number of carbon atoms, then highest number of carbon atoms. That is the opposite trend of bicyclo compound. In bicyclo compound, we have to consider first, that is highest number of carbon atoms present in any side of the ring, then lowest number of carbon atoms present in the ring. But in Spiro, we have to use opposite trend, that is lowest number of carbon atoms present in first, then highest number of carbon atoms is present in second. Okay, like for example, in this structure, there should be in one side 3 carbon atoms is there, in other side 4 carbon atoms is there, but in bracket, as it is Spiro compound, we have to consider 3 then 4. Okay.